Hey everybody, it's Mr. McCall here, and today we are going to go over graphing. This is the first practice assignment, but it'll also probably live in the tutorials as well, just so that you guys have the ability to look back on it easily. This is essentially to help you understand the protocols for doing graphing, and this is applicable to just about everybody in different courses, but it's also very particularly important to ACE marine science students because these are the protocols that you're going to be graded on. All right, so just keep that in mind. However, these are the same kinds of things to think about for any science application and course that you're taking as well. So, having said that, we're going to jump in. Now, the first thing in this assignment is mostly just listening to me talk, going over the protocols sheet. You're also going to have two exercises to complete where you're going to actually create graphs, and you're going to create graphs on a blank sheet of graph paper. Now, because we are doing things a little bit more paperless, at least on my part, giving it to you, I need you to be able to hand complete the graphs because that's how ACE Marine students are going to be tested. All right, you're going to have to do that on the test. And because I'm not passing out graphing work specifically for you to work right directly on, we need to do it in another way. So make sure you have your graph paper. You're going to do two exercises, two graphs in each one in each exercise. So you're going to need two sheets of graph paper for this assignment. Okay. But before we get to that, let's give some overview and talk about graphing. So I'm going to do a present my screen just so we can all see the same thing. All right, here we go. So here is the assignment that I have handed out, the graphing guide and practice. Okay, so this is going to go over the protocols. Now, again, you will be given on an ACE test, for those of you doing ACE Marine, graphs, and you will have to interpret them. You will also be given data, and you will have to graph it. So it goes both ways. And in all my other classes, you're going to be doing the same sorts of things anyway, because guess what? You're in a science class, right? And science is all about data. So here we go. Number one, start with the question and the data provided. This is an example from an ACE Marine test, an old one. It says, plot a graph based on the mean rate of respiration of the fish against temperature and draw a line of best fit. Now, a couple of nice things about this particular prompt is that it tells you what kind of graph you need to do. Line of best fit, right? Which is kind of nice. It's a form of line graph, but it's actually a scatter plot is what it is. And we're going to talk about the different types of graphs in just a minute. Now, questions will not always tell you what type of graph to use. Sometimes you are going to need to develop a sense and make sure you know, oh, okay, this is the type of data being given, the scenario. That means this particular type of graph is going to be best. So just keep that in mind. Now, when you're looking at a table that you have been given, you can dissect it in a couple of ways. And here's two good guiding rules to determine what data sets are going to go on which axis of your graph. For the x-axis, the guiding rule is the first column in a table is going to be the independent variable, and thus will be graphed in the horizontal axis. Okay. And then the y-axis is generally going to be the second column, and that table is going to be, and that's going to be the dependent variable. That's what's measured. And you'll graph that on the y-axis. Okay, so x-axis and y-axis. Now, understand that you need to know what the x-axis and y-axis is, because if for some reason you're given a table that's not set up this way, doesn't generally happen, but every once in a while there's some weirdness, you need to be able to catch that. Okay, what is the independent variable? It goes with the x-axis. What is the dependent variable? It goes with the y-axis. That kind of a thing. All right, number two, choose the appropriate graph type. All right, decide which type of graph is best appropriate for the problem. The directions will either tell you what graph to use, or you will have to actually choose yourself, okay, based on the problem. And there's a few different things that you can look at. Obviously, line graphs are probably what most people are used to seeing. Know that you're using that when you're doing things like change over time, distance. Time is on the x-axis, right? So just keep that in mind. Scatter plots, or the line of best fit, these are correlations between two sets of data, varying one variable, the independent variable, and measuring how it affects the other variable, the dependent variable. So independent variable is graphed along the x-axis, just like we said before, and the dependent along the y. Now, bar graphs are when you're comparing various different sums of groups and groups together. So two or more groups you are comparing, like the different colors of hair within a classroom, or the different colors of apples in an orchard, how many of each are being grown, that kind of a thing. You're comparing those different groups. You're going to use bars that represent the data, and those bars need to have equal gaps between each bar. All right, just something to think about. Histograms are bars that touch. They display a distribution of data. Bars are actually connected in this sense, in this particular instance. We're not going to get into histograms too much, and we'll have some practice somewhere along the way. Pie charts, of course, are those lovely circles all separated out like a piece of pie, where you have various parts of the whole. Okay, so just keep in mind that you are not always like up here where it gives you line of best fit. If that wasn't there, you're looking at mean rate of respiration of fish against temperature. That's telling you that essentially what this is, the correlation between two sets of data. All right, that's probably going to be a scatter plot and a line of best fit. So keep that in mind. Now, you will generally, number 3, you're going to have to scale your graph. You'll always be provided, in the ACE exam at least, with a graph that's actually sized out perfectly to what you need. It's just going to be blank, very much like this. You'll have a graph like that. And that graph should be able to fit the data that's given, because ACE has figured this out. They know what they're looking for, what the graph is supposed to look like. And so they've given you a graph to be able to do that easily. You need to choose a scale that fits the graph appropriately. Now, there's a couple of things. Here's some guiding rules. The graph provided will fit the data, which we've already talked about. Number 2, make sure your values fit evenly across your graph. Properly scaled is essentially the concept. Let's say I only used this much of the graph to make my graph. You would lose points. You need to use the entire graph, all right, the entire graph space, or you will lose points, okay, when given on a test. So in doing so, you've got to figure out how to make these numbers fit all the way across the x-axis and the y-axis, okay? That's what you need to do. Now, down here gives you a little bit of a breakdown on how to do that, all right? For the x-axis, in this particular instance, you can tell that the data is evenly divided. You've got, and this is degrees in temperature, right, in degrees Celsius, 10, 12, 14, 16, 18, 20, 22. There's 2 increments of 2 across the board, right? So you can use that to apply to your graph, right? Down here, we're looking at the y-axis. In this case, what you want to do in the case of this kind of a range is your minimum number is 0.13. Your maximum is 0.27. If you subtract the 2, you're going to get a difference of 0.14. Now, from there, you can start to work with your graph itself and try and design a method to divvy out those numbers across this distance. The key thing you want to think about is making sure your increments are as close to kind of easily divisible numbers as possible. Like, you don't want to do 0.78 increments. Like, that's going to be weird. You want to do increments of 1 or increments of 2 or increments of 0.2, 0.5, something that's sort of evenly divisible as you go up each square, right? Or every 2 squares, that kind of a thing. Now, I'm going to show you in this particular instance what this is going to look like. And this is it. So here, if you look at how it's divvied up, you look at the distance across here for the x-axis. starts with 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right. Now, some might actually start with 8 over here just so you have a little bit of breathing room. That's fine. You can. Just it needs to be relatively succinct. You don't want to start with 0. If you started with 0 and went 0 to 2 to that increments 4, 8, sort of, that's going to be a huge section of your graph that there's going to be no data on, right? So you want to start close to your first set of data. In this case, it's 10 degrees Celsius. So this is a nice evenly spread situation. Now for the y-axis, here we got 0.13. So what they basically figured out is if you divided, you took the difference between the two, divided them up, you can do increments of 0.2. So 0.02. So 0.13 plus 0.02 equals 0.15. Add another 0.02, you got 0.17, 0.19, 0.21, 0.23, 0.25, 2.27. Now, if we go back up to the data set, sorry, I'm scrolling here. If you go back up to the data set, you'll look at this, 0.3 to 0.7. You got it. And it's now equally spread out. All right. Now here's the catch. You are going to be working on a blank sheet of graph paper. So you're not going to have a square to work with. Okay. But that does not mean that you shouldn't follow these types of guidelines. You know how you want your graph to be of a decent size on the page. You don't want to be a little tiny. You don't want to be really like so big that you can't put your labels on your graphs, things like that. So you need to plan it out. All right. We are going to now look at what the actual, here we go. I'm going to go back to here. So let's go to now what you do. Now what you're going to do is graph your data. All right. Once you have your graph scaled, it's time to graph. In this class, you will be using an X to mark the points on your graph. Do not use a dot or any other method. Now, you can put a dot there for the point and then put an X with the dot at the center. That's fine. But you want to use an X. Mark all data points with an X, cross bars, right there. X marks the spot. Another guiding rule. Draw graphs using a pencil. You're using a pencil, not a pen. You're allowed to use a pencil for a very good reason. If you're drawing a graph, it's most likely that you're going to mess up somewhere along the way. We're human. We all do. You need to be able to erase and change and figure things out, right? So pencil is key. This is the only part for ACE Marine students of the exam that you can use a pencil on is the graphs. Everything else must be pen. So just keep that in mind. And the third guiding rule is use a ruler for drawing lines at all times. That means lines of best fit, connecting lines, bar graphs, you use a ruler, okay? Or you will lose points. All right, so now let's get on to the first exercise, okay? Now I'm going to switch over to an aerial view of this because you're going to be using your own graph paper. I am going to practice that myself, and we're going to go over this particular set of data. Table 1.1. So couple of things as we go through this. It is going to be a scatter plot. The guiding rule for scatter plots is the best fit line does not go beyond the graph, and you're going to try to connect as many of the points as you can with equal numbers of points on either side of the line, or as equal as you can. And in this particular example, we'll show what the results are here in a minute, right? So this is the one graph. The second graph you're going to do, we'll get to in a minute. So let me switch over to the aerial view and let's draw out this first graph together. So now that we've figured out the scale of the graphs, we know kind of what we are going to be graphing. We're graphing a scatter plot. Now it's time to actually build the graph. Now remember, on the ACE exam, you're going to be given a piece of a graph, or basically a graph, blank graph, that you are going to use. And that's a little easier because you can sort of map it out because they've already mapped it out. They know that they've given you a graph that's the proper size. Now, while we're doing this practice with a whole graph sheet of paper, you're going to have to create the entirety of the graph. So understand the difference between the two. But we're going to go ahead and start by making my axes. And I'm going to kind of work with the Y first. And remember, you always want to use a ruler so that everything is nice and clean and structured looking. Okay, it looks very professional. Now I've created my X and Y. Now I'm going to start with the Y axis here, and I know that if I subtract the 0.13 by the 0.27, you get a difference of a 0.14. Now we're going to divide that up. Now in the graph that actually ACE gave us for this particular question back in the day, you essentially had 7. So the best way to do that if you divvy it up would be about a 0.2 difference between each increment. That makes a certain amount of sense here. Now, if I give you a graphing problem, and obviously you don't know the size of the graph, do your best to make as clean and concise increments that spread a large enough area that it makes sense. So still, you would go through that process of what's the highest and the lowest number, and then kind of figure out, well, how many brackets do I need to use to make it a clean number? So in this case, we're going to start down here with 0.13, right? Then we're going to come up 0.4, 0.5. So this is going to be our 0.15. Then 0.5, 0.6, 0.7, 0.17, 0.8, 0.9, 0.19, 20, 0.21, 0.21, 22, 23, 0.23, 4, 25, 0.25, 2.27, 25, 26, 27, so 0.27. All right, so now we basically have our y-axis labeled out. Now we need to do our x-axis. Our x-axis is an even increments between 10 and 22, 10, 12, 14, 16, so we can skip 2 again. Just to give us a little bit of breathing space, I'm going to start here. So we're going to start with 10, which would leave this to be 8. This is, of course, temperature. 11, 12, 14, 16, 18, 20, 22. All right, and I will end the graph here, which would be 23, 24. So I'm going to go ahead and create my other side of my graph. Here we go. And I'm going to do the same here. I'm going to cut off right about 27. I'm actually going to cut up right above it, as close as I can. But now this is why, of course, you use rulers. Obviously, in the ACE exam, it's not because you're going to be drawing the entire graph itself, but as you make mistakes and things like that, you can adjust it. Okay, so now we are going to go ahead and work on the x-axis and y-axis labels. So we're going to start with the y, and I'm going to write exactly what it says: the mean rate of respiration per milligram O2 consumed per hour per kilogram of wet mass. Okay, and of course the x-axis is much easier. We're just looking at temperature, degrees Celsius, right? Now, of course, I'm always going to label my graph. Now, this doesn't necessarily happen as much in the ACE exam itself unless it's asked, but I would, if you can, especially in my assignments. You're going to go graph number 1. Always number your graphs. Again, this is more of a general science thing, not an ACE thing. Rate of respiration versus temperature. All right, so now I am ready to plot my data. So I might actually go and do a little pencil sharpening here. All right, so now let's look at our data. At 10 degrees Celsius, we are at 0.13. So I'm going to make my X here, and that's my point. Now, at 12 degrees, we have 0.14. So we are going to go up to 0.14, which happens to be right in the middle here. Make my point, do my X, right? Now at 14, we're at 0.15, which happens to be right here. So I'm going to make my point. I'm going to create my X. All right, now we're at 16 degrees, and at 16 degrees, we're at 17. So I'm going to make my point. I'm going to make my X right on that point. Now I'm going to go to 18 degrees, and at 18 degrees, I'm at 0.19. So there's my point. I'm going to make my X right through the point. Now we're going to go to 20, which at 20 we have 0.23. That's way up here. So there's my point. I'm going to make my X. Now we got 22, which is at 0.27. So we're going to go all the way up to 0.27, which is right here. Make my point, make my X. So there are all of my points plotted. Now we have to figure out the line of best fit. Now, the line of best fit is going to go through as many points as we can in a straight line and have as much equal number of points on one side of the line versus the other. So as I'm working with my ruler here, I'm looking around. Well, if I do between these 2 points, everything is on the right side here. That's not going to work. If I do these 3 points that are not nicely lined up, yeah, I get 3 points, 1, 2, and 3, but all the other points, 1, 2, 3, are on the other side, so there's no equal here. Now, if I put the line straight through these 2 points, I have 2 points where the line is now going through. I have 3 on one side, 2, which they're under the ruler, on the other side. That's the best fit line. So the lines should not go past the graph. You will lose points for that. Okay? So this is a properly constructed and labeled graph for a scatter plot and a best fit line. You have your points of data that are put down with the X, right? You have a scale on both the X and Y axes that makes sense. It's easy to read. It's easy to jump from number to number. You have full labels on your variables on your X and Y axis. You have a title. Everything was done in a ruler. It's clean. We are good to go. This is going to get you full points. All right, guys, welcome back. We are going to go ahead and now switch back over and look at what the second exercise is going to look like. Now, exercise 2, using your own graph paper, so this will be a separate piece of graph paper. Here is the prompt. Shrimp fishing generally requires the use of small mesh trawling nets. This results in an increased catch of non-targeted species, otherwise known as bycatch. Big deal in the world, right? Research into the different species found that bycatch of Nephrops, Dublin Bay prawn, fishing was carried out by the Belgian Fishing Ministry. The findings are shown below. So here you see table 1.2 bycatch in tons, and that's the British way of saying tons, by the way, spelling tons, by the way, just so you know. I looked it up because people kept asking me. So catch in tons during Nephrops fishing. So in this column, the first column, we have the number of landings or tons. Now landings would be how essentially taking the fish and bringing it to shore, that kind of a thing. And then the percent of the total landing. Now here you've got Nephrops, 552 tons, 35.2% of the landings. Now, as you go down, you'll see the number for plaice, whiting, sole, cod, rays, and others. Notice there's a total here. All right, here's the example ACE question. Calculate the percentage of the landing that was plaice. Record it in table 1.2. Now, you'll notice that there's a blank here. That's essentially telling you to write the proper number in that blank based on the data that you see here. Now, in our particular assignment that you're doing right now, because you're just writing two graphs on a graph paper, obviously you're not going to be able to do this. You're looking at a PDF file. Don't worry about it right now. But I do want you to figure out that number because you should be using that to graph with. Okay, so just keep that in mind. However, how do you create a percent of total landing? I'm going to let you think about that yourself, and we might talk about it in class. But this is pretty basic math. And like I said, we will go over it, but I'm going to leave it be for now. What I'm going to focus on is the part B here. Plot a graph showing how percentage of total landing varies with the different species. Okay. Graph showing how the percentage of total landing varies with the different species. We're comparing between all these species. Folks, this is a bar graph. All right. These would be essentially your x-axes. You're labeling them out, right? And then of course your percentages you're going to need, because it says how percentage of total landings varies. You are not doing anything graph-wise with these numbers. All right, this is where you have to pay attention. In this particular instance, you're going to use all of these numbers to graph. You're going to use this for your categories, for your bar graph, and you're going to do nothing with these in your graph. Okay, but you didn't need that number to calculate this percent. So just keep that in mind. Now, I'm going to let you do this on your own. I have some additional guidance here for you to look at as we go. Couple of just hints as you go through this. If you are doing a bar graph, make sure your bars have equal width, okay, on your graph, and make sure the spacing between the bars, because there should be spacing between the bars, is equal across your graph as well. You can just do a light shade for the interior of the bar, okay? Those are some very basics. All right. Stop presenting, and we're going to turn it back to you to finish this assignment. And we're going to go over things obviously in class. I hope this was helpful.